Hello, everyone. Good morning, good afternoon, or good evening, depending on where you are joining us from today. Welcome to JuiceFS Office Hours number 5. It's great to see familiar names in the chat and some new ones as well. Before we dive into the technical content, looking at the calendar, we are fast approaching the end of years. So on behalf of the entire JuiceFS team, I want to wish everyone a very Merry Christmas and a Happy New Year in advance. Whether you are taking a break next week or working through the holidays, we hope you have a wonderful festival season. And I have a few quick but important community updates to share with you before we start today's workshop. First, exciting milestone for all enterprise users. JuiceFS Cloud Service has officially passed the SOC 2 certification. Security and compliance are our top priorities. If your organization is currently using JuiceFS Cloud Service and requires compliance report for your internal auditing, please reach out to us and we will be happy to share it with you. And the second, this platform office hours is not just for us to talk, and it's for you to share. So we are officially opening a call for proposals for your future session. We know many of you are using JuiceFS in fascinating ways across many industries and scenarios. We want to hear from you, user stories, your unique use case, and even your challenges. You can share them in our Slack channel or simply click contact us on the JuiceFS website. And we would love to invite you to join us here as a speaker or set a time at your convenience to share your experience with global community. And lastly, quick notes on logistics. We realize that our current time slot may not be friendly to our global users across different time zones. We really want to make this community accessible to everyone. So please let us know your suggestion, whether it's about timing, the format, or the platform. We are eager to hear how we can help more users participate. Beyond feedback, I'd like to share some impressive momentum from 2025 community updates. This year, we've seen above 300 new issue and over 600 merged pull requests. Our contributor base is also very diversified with 16 total contributors, including 32 new faces who joined us this year. And on the software side, we released the version 1.3 LTS version in July. We're also actively maintaining several patch versions, so you can see the version list on the slides. This activity translates into massive community edition growth. So we receive anonymous telemetry data voluntarily reported by our community users, and according to these statistics, we now say near 600,000 file systems, and 82% increase, and more than 150,000 active clients, and the total data volume has surged by 89% to over 1.3 exabyte, covering more than 400 trillion files. To give you an idea of scale, the largest single volume we know of a currently managed 170 billion files and over 500 petabytes of data. Our metadata engine continue to push boundaries with TechKV supporting up to 100 billion files, while PostgreSQL and Redis both handle 1 billion. All right, let's get into the main session. Today is also a hands-on workshop where we are dive deep into how to use JuiceFS in Kubernetes to provide that scalable, high-performance storage you need. We know that getting started can sometimes bring up questions and about volume mounting permissions or configurations. That's exactly what we will solve today. Here is our agenda for the next 20 minutes. First, our engineer Qing Jiang will walk us through a live demo. After Qing's demo, we'll have a live Q&A session. So please feel free to drop your question in the chat box or Slack channel at any time. So now I'll hand the stage over to Qing. Qing, the screen is yours.
Thank you, Sue. So how's everyone doing? So today's office hour will cover your favorite topic, I suppose, the how to using the JuiceFS in Kubernetes. So without further ado, let's get started. Okay, so first let's go open the JuiceFS.com website and go to the documents. JuiceFS CSI Driver. And from the introduction part of this document, you can see the 3 modes supported by the JuiceFS CSI driver. By the way, the CSI is short for the Container Storage Interface, which is the standard interface in the Kubernetes ecosystem to allow the storage vendors to provide the storage capabilities through the standard way. So that's the CSI driver. So 3 modes provided by the JuiceFS CSI driver. The first one, or the default one, or the one we recommended, is the mount-pool mode, right? So essentially, the CSI controller will drive the node service to create a mount pod, and the mount pod is running the JuiceFS client to provide the storage capacity to the application part. But I realized that in some scenarios, your Kubernetes vendor may not allow you to create the daemon set of the node service, which is required in the mount part. So we also support the so-called the sidecar mode, which doesn't require the daemon set, and we also support to mount directly inside the node service. But today's session, we will not cover the rest of the tool. We will mainly focus on the mount-pool mode. So let's go back to the architecture diagram of the mount-pool mode, and you can see that the mount-pool is being managed or created and monitoring by the node service, which is running in the demo set, right? And in each mount pod, actually running a JuiceFS client in the front end mode, and essentially connect to the metadata engine as well as the data storage, and provide the storage capacity to the application path through the container storage interface. All right. So the mount-pool mode is recommended because it's easy to understand and easy to set up, and also it could be resource optimized. For instance, we support to share the same mount pod across different application pods. So you don't have to create a mount pod per application pod. So multiple application pods can share the same mount pod. It doesn't like the sidecar mode, right? So and that other benefits, I encourage you to go to the document website to go through the architectural chapter for the description of the mount pods as well as other modes supported by the CSI driver. And now let's go ahead to install the CSI driver. Okay. The recommended way to install CSI driver, of course, is through the Helm chart. So this command here. Let's go ahead to my console. And install the Helm chart. Oh, by the way, so this Helm chart is by default, installed in the default namespace. And I actually wanted to install in the Kubernetes system. So and change it a little bit. Let me install the Helm chart first. And then install the chart in the Kubernetes system namespace. So we install it as a taking all the defaults, but we actually support like a lot of customizations of the CSI chart. So it's actually in the documentation. If you go to the installation, Helm chart, and the values, it's a list of the tons of values you can customize the CSI driver. For instance, you probably want to customize the size of the mount pod, because the mount pod is a pod you need resource to run, right? So if the mount pod is shared by multiple application pods, or have a heavy traffic through that, you probably need to consider increase the resource request by the mount pod, right? So this is the part for the resource, and also of course the mount options. You introduce the mount options to optimize your JuiceFS performance. For instance, the cache, the read ahead, write cache, something like that. All these mount options which support as a standard JuiceFS client can be customized here. So we actually will cover how to customize the CSI driver, as well as how to do the troubleshooting, monitoring as our follow-up CSI sessions. We actually planning not just one, but the 3 CSI sessions, and I believe the next 2 sessions in 2026 will cover more advanced topic about how to configure, manage, and also performance tuning of the CSI driver. So looking for our announcement in a Slack channel to see when the next session started. Okay, so let's go back to the installation. So for this session, I'm going to take all the default values and just install the Helm chart. Okay, took a while. And then there's a quick command to see if all these parts for the chart up and running. So you can see we have several parts being created by the Helm chart. The first is the controller. We have 2 controllers, right? And then, because if you recall the architecture, we have this node service daemon set. So since in this cluster, I have multiple nodes, so it will, as a daemon set, create one pod per node. So you can see this a bunch of CSI nodes over there. And this container, it's actually running a dashboard for the CSI chart, which is very useful because it provides a web interface to you to view, monitoring, or even interact with the pods created or managed by the CSI. So let's go ahead to bring the dashboard up. So it's up already, by the way. So what we need to do is to do a forwarding, so we can open the pod, open the dashboard in our local browser. There we go. So it's the dashboard for the CSI driver. Currently, it's empty since we haven't created any persistent volumes or storage class. But if you go to the system part, you may see exactly what we see when we check the CSI pods. There are no services, the dashboard pod itself, and that's the controller, right? So if you click one of the pods, you can look at the logs of the pod, and it also shows you the version of the CSI driver, and you can even create a terminal to check the JuiceFS version over there, right? So it's very very handy. So we will go back to this web dashboard later during the session when we do some more configurations over there. Okay. So that's the installation of the CSI driver through the Helm chart, just one line command, so easy. And then we are going to start to provision some storage. Okay. So before we do that, let's go back to the introduction, and we can see that's actually in the monitoring mode we have two ways of provisioning. So one is called static provisioning, and another is called the dynamic provisioning. So the static provisioning, as is shown in this diagram, is essentially provision a static persistent value, right? So it's one persistent value, and your application can use it by select the value using the persistent value claim, or PVC, right, through the labels. And the persistent value is actually referencing to the secret, which pointing to the metadata server as well as the storage. And that's where we're going to set up. So we are going to set up the secrets, and then we create the PV, and then we in your application namespace, we create a PVC as well as a test pod. So let's get started. So I already prepare for the secret. So you can see the secrets option is essentially the same when you do a JuiceFS format, right? So you need the name of the file system, your meta URL, storage type, your buckets endpoint, as well as the SS key and a secret key. I'm not supposed to show you that, but yeah. So that's the secret. So all these parameters needed is when you record the previous session, we talk about how we use the community edition to do a JuiceFS format, and all the parameters are actually here. We put into a secret in Kubernetes, right? So let's go ahead to apply. Yeah, that's our secret. Okay, so after that, we are ready to create the persistent value. So the persistent value, it's essentially a very standard value, except for the CSI part. We are pointing to the CSI driver, and also it's important. We need to pointing to the right secret, the secret we just created. So the secret is it need two parameters. One is the namespace, and then the name of the secret. And by the way, in the document, we have a complete example here that you can refer to. Actually, I just copy the example from the document and remove all these commands, right? And then that's my YAML files coming from. And our document is very detailed about each individual attributes and what is the value, and also referring to our JuiceFS client documentation over there, right? By the way, so this extension is covered the open source edition, but I think the CSI it also supports the enterprise edition as well as our SaaS offering. So there's an examples to how to use that on that edition also. Okay, and then we can go ahead to do to create the persistent value. Okay, so the value is being created and the status is available. And also, if we go back to the CSI dashboard, yeah, we can see the value we just created is listed here. So status is available. It actually shows you all the status. Currently, they don't have any PVC associated with it. But yeah, that's the PV. You can list all the PV, the persistent values you create through the CSI driver. Okay. So once the PV is ready, we can go ahead to create a PVC as a test port in the applications namespace. So it's recommended to create a secret in the CSI drive namespace, so that can be managed in the same space, and then of course the PV is namespace independent. And then your PVC, of course, is in your application namespace. Okay. So if you maybe like secret node found, or could not connect to the Meta, you probably, when you create a PV, you forgot to referencing to the right secret, or the namespace is wrong. So you probably need to do some diagram to before you apply or set up the JuiceFS CSI driver. Okay, so our PV is ready. So let's go ahead to create a PVC under the boot club namespace, which is my application. Okay, and see. Okay, so our PVC is being created and mount. We also like to take a look of the PVC, and Yeah, so the PVC is quite straightforward. It's using the selector match labels to select the JuiceFS name, which is defined in the PV, right? And then the access mode, right? And that's it. Okay. And also, you can always using the examples in the documentation. Okay. Now let's go back to the CSI dashboard and see the PVC. You can see it's already been created. And the PV shows it's been bounded through by this PVC. Okay. So the PVC is ready. We can go ahead to just use it. So I create a test pod, which using this PVC and mounting to slash JuiceFS mount point, and it's do nothing. It just echoed current time to a file, which is inside the JuiceFS mount point. Okay. So let's go ahead to create a pod. So it takes a while to download the container image and start up. Okay, now it's up and running. So we could go into the part to see what it's doing. So in the application part, this is the part we just created. It's actually using the PVC, and you may notice a mount part is being created. So like we just example for the static provisioning, right? So after we create a PVC, it's actually a mount part has been created by the JuiceFS CSI node service, and to provide the storage, right? So in this dashboard, you can exactly see this particular mount part here. And again, the mount part is the part running the JuiceFS client, right? So we can actually look at the log of the JuiceFS client, which if you are in a like a standalone installation, is actually under the path /var/log/JuiceFS.log, right? So this is exactly the same log from the JuiceFS client. And we can even log in to this mount part to check the version, right? Essential. Okay, so that's conclude today's hands-on session. So we cover how to install the char, and then create to do a static provisioning by create the persistent volume, the PVC, and then a test application part to using the storage from the JuiceFS. And we also shows you how we using the dashboard to monitor, or to list and monitor the whole thing. Okay, so actually the dashboard have more use. For instance, we can custom the the mount options here. We can even do a bench upgrade of the mount pods through the CSI dashboard. So there's a more advanced topic over there about CSI, and I think there's a lot to cover. So that's why we have two feature office hour sessions, well, dedicated for the usage, or I would say advanced usage of the CSI driver. Okay, that's conclude for today's hands-on. So feel free to post in the chat if you have any questions.
Thank you, Qing, for that comprehensive walkthrough, and thank you to everyone. It's great to see so much interest in the cloud-native storage experience. We'll be publishing the replay on our YouTube channel. So if you'd like to revisit the session or catch future workshops, please subscribe or to stay updates. Now we're opening up the live Q&A session. Please post your question in the YouTube chat. We'll repeat and answer them here. Okay. Yeah. Let's wrap up a session for the day. We covered the essentials and getting the JuiceFS CSI Driver installed, navigating the dashboard, and creating your first static PV. But I know many of you are running complex workloads and need more automation. So I want to give you a preview of our next office hours. We'll be diving into advanced CSI configurations. And before we sign off, two quick requests. First, if you want today's session helpful, or if you simply like what we are building, please head over to GitHub and give JuiceFS a star. It's really helped us as the project grow and reach more users. And second, if you try out today's demo and run into issue later, don't struggle along. Join our Slack community. All engineers and other users are there to help. Once again, wishing you a very Merry Christmas and a Happy New Year. Enjoy the holiday, recharge, and we'll see you in 2026 with more exciting updates. Goodbye, everyone. Goodbye.
Happy holidays. Bye-bye.